Good day and welcome back to another chemistry lesson with Mr. Simons. Actually amazed that what flu I've managed to get this far, but yeah. November 2020, Eastern Cape paper, question 3, again, boiling, melting points, vapor pressure, etc. Right? So let's look at the question. Say the boiling points in the table below were obtained during an investigation carried out to compare the boiling points of group 7 hydrides. The hydrides HCl and HBr are labeled in the table as compounds A and B respectively. So HCl is a molecular mass of 36,6, HBr 81. So bigger molecular mass, boiling point, lower, higher boiling point. Should know minus 66 is bigger than minus 85. 3.1.1 define the term boiling point, which by now you should know. In what phase are compounds A or B at 0 degrees Celsius and at 101 kilopascal of external pressure? 3.1.3 name the type of intermolecular force that exists between the molecules of both compounds A and B due to the polar nature of their molecules. So Cl and bromine are both halogens, hydrogen are both from group 1. Which one of the compounds A or B has stronger London forces or dispersion? Give a reason. So we're going to look at molecular mass of those two. Which compounds have the higher vapor pressure? So for highest vapor pressure, lowest boiling point. Right, then we have compound C, not shown in the table, has a smaller molecular size than both A and B, but has a relatively higher boiling point. So the bromine, chlorine, fluorine should be above it, right? But they have fluorine and hydrogen. We're looking at a hydrogen bond. Explain why the boiling points of compound C is higher than that of compound A or B by referring to the type and strength of intermolecular force for 3 marks. And then we have a second set of questions. So you can pause here, attempt to answer this. Solid iodine is added into equal volumes of carbon tetrachloride and water in separate test tubes as shown there. So we have carbon tetrachloride and iodine is added to it. And there we have water and iodine. In which liquid, CCl4 or H2O, will the iodine dissolve? So remember that concept of comparable strength. And then explain the answer. Alright, so the intermolecular forces must be either of the same size for them to dissolve. So define the term boiling point. It's the temperature at which the vapor pressure of a liquid equals atmospheric pressure. So vapor pressure and atmospheric pressure must be equal, 2 marks. Right, in which phases are compound A and B at 0 degrees Celsius and at standard temperature or pressure, 101 kilopascal. So there they both boil before 0 degrees, so they both in gas phase, right? Name the type of intermolecular forces that exist between the molecules compound A and B. Due to the polar nature of these molecules, they both dipole-dipole. Alright, meaning a positive negative side combined with a slightly positive negative side when they're sharing electrons. Which one of the compounds A or B has stronger London forces? Give a reason for your answer. So, yeah, bromine is a larger molecule than chlorine, therefore bigger molecular mass, stronger London forces. So therefore B, compound B has a larger molecular size. Right? Bigger molecular size, stronger intermolecular force. Very important you know that. Which compound A or B will have the higher vapor pressure? So A, because it has the lower boiling point, right? Then they say compound C, not shown, has a smaller molecular size than both A and B, but a relatively higher bond. So when can it be smaller but have a higher boiling point? That only happens when there's hydrogen bonding. Alright, so compound C, which in this case most probably is hydrogen fluoride. When fluorine, oxygen or nitrogen combines with hydrogen, we have a hydrogen bond. No? Hydrogen bonds are stronger than the dipole-dipole forces in A and P, right? And because there's more energy needed to break a hydrogen bond, more the boiling point increases because the intermolecular forces are stronger. Does that make sense? So compound C has hydrogen bonds. Hydrogen bonds are stronger than dipole-dipole forces in HCl and HBr. Therefore, more energy will be required to overcome the intermolecular forces in HF. I hope that makes sense. Alright, let's go look at the last set of questions. So solid iodine is added to equal volumes of carbon tetrachloride and water in separate test tubes as shown there. In which liquid will iodine dissolve? So first, carbon tetrachloride. Explain the answer. So carbon tetrachloride, iodine both have London forces. Right, H2O has London and hydrogen bonds. Right, so there, these two are not comparable in strength, but those two are comparable in strength. The intermolecular forces are more or less the same. So intermolecular forces in solution are of comparable magnitude, CCl4 and iodine. Therefore, they are able to dissolve in each other. Right, I hope all these lessons are useful. Work through it. God bless. Bye.